Today we're going to do an experiment we've been putting off for a while. Here we've got 15 grams of dry liquid pyridine. We're going to attempt to reduce the aromatic ring of the pyridine to form piperidine. A pretty serious reduction. And it's going to call for a serious reducing agent. And here it is. The whole 56 grams of sodium metal chunks. We pre-weighed it and then put the lumps of metal into the beaker with some dry mineral oil in to protect it from atmospheric moisture. You can see there are a few bubbles coming off, so maybe our mineral oil isn't as dry as we thought. 56 grams is a lot of sodium metal. Nearly 2.5 moles. But each pyridine ring needs 6 hydrogens adding, and we're adopting the Orgson recommendation of using twice the stoichiometric theoretical amount of sodium metal. We're then added an extra pinch for good luck, making 13 mole equivalents of sodium compared to the pyridine. We'll need to cut it into smaller chunks which will fit through the neck of our flask, but we'll do this as we need to. Here's the setup for the first stage. We're using the 500 ml flask, but we strongly recommend you use a larger one or cut down on the reaction scale. You'll see why. Strong stirring is also very important. And use a large efficient reflux condenser. The big condenser will not work. Trust us on this, or keep watching and you'll see why. First we add the 15 grams of pyridine to the flask. And now for our solvent and reactant, absolute ethanol. Note it must be completely water-free unless you like third-degree burns. We're going to start off with about 200 ml and see how we go. We'll add more as we need to. Note that you'll need about 350 ml of absolute ethanol in total. Now we're ready for the fun part. Let's get a couple of nice big lumps of sodium. Dry them with a paper towel to remove the mineral oil as best you can. And it's showtime. Let's get a few more lumps in and then we'll get the reflux condenser on fast. It's very pretty to see the silvery shiny pure sodium metal exposed on the lumps. But as often the case, with prettiness comes a mean streak. The temperature steadily increases and the mixture turns a yellow and then definite orange color. This is slightly different to sodium reacting with just pure ethanol. And then, as we reach the boiling point, the reaction kicks off. And boy does it kick off. The sodium gets hot enough to melt into a ball in the center of the flask with the stirring. After about 5 minutes the reaction dies down again. Time to add some more sodium metal. Again there's a vigorous reaction. Not quite as vigorous as the first one though. We let this react and die down again, which takes slightly longer. Still got a lot of sodium to go. The molten sodium balls really are very pretty. We wonder what would happen if the flask broke right now. But there's only one way forward. At this point the reaction slowed right down, and we could see the sodium ethoxide starting to crystallize out in the mixture, forming a gel. We kept going and added a little more ethanol bit by bit to the flask to keep the mixture liquid and stirrable. The last part of the sodium to go now. So let's throw caution to the wind and get it all in there. The reaction is now quite slow, and we needed to add a lot of ethanol and wait quite some time for the reaction to complete. We'll let you watch the end of the reaction and we'll be back in a moment. We discovered the trick. Add 30 ml of methanol near the end and the mixture liquefies much more easily. The sodium has all reacted and we've got the clear solution. So now comes the boring part. We've got to distill off the ethanol and very slowly add water to the mixture to hydrolyze the sodium ethoxide, then add more water and steam distill off the pyridine. So we set up for distillation. Pretty quickly we've got ethanol coming off. After a while we did an experiment and injected a very small amount of water, just a few drops, into the boiling flask. It's a very vigorous reaction as the sodium ethoxide is hydrolyzed back to ethanol and sodium hydroxide. There's a white solid formed in the process as well. Go very slowly or your mixture will for sure boil over. This is why we recommend using a larger flask. To start with, add just a few drops at a time, then work up to a ml, then a few ml. You can see the white sodium hydroxide forming. During this process, distillation of the ethanol is occurring, and this takes some time. To add the first 100 ml of water and collect the first 200 ml of ethanol took about 2.5 hours in total. After this point the water addition process became easier and we were able to add carefully in 25 ml portions to the boiling mixture. We added about 200 ml of water in total to the reaction mixture and kept distilling. Towards the end of the water addition, the solid white sodium hydroxide in the boiling flask started to dissolve, and eventually formed the solution. And soon it's only water and pyridine distilling off. Eventually we're down to a few hundred ml of liquid remaining in the boiling flask, and the vapors coming off only have a faint aroma of pyridine. So we stopped distilling at this point. The last water portion of the distillate was quite cloudy as you can see. The boiling flask contains a highly concentrated sodium hydroxide solution, and some yellow residue, possibly from the mineral oil. Well, we hope our flask wasn't too weakened from the alkali solution boiling for so long. In total we've collected about 500 ml of distillate, which is pyridine dissolved in ethanol and water. Let's check the pH of the solution. Strongly alkaline as we would expect. There may also be some sodium hydroxide that made it over in the mist from distilling those as well. We've got about 25 ml of 20% hydrochloric acid here. We're going to use this to convert all the piperidine into the hydrochloride salt in the solution. The effervescence does suggest that there's some sodium hydroxide that's made it over and converted into sodium carbonate via the CO2 in the air. We've added carefully checking the pH, so let's try one last time. Slightly acidic, which is perfect. Don't add too much acid or you'll have trouble removing it later. And now it's time to distill again. This time to remove the ethanol and the water from our salt. This time we're using the nice big flask. And although the ethanol will be azeotropic, we'll get the fraction boiling at about 80 degrees C and save it just below 80 now and boiling. Distillation of the ethanol took about an hour and a half. And then the temperature rose and we started to get water distilling off. Once the mixture was reduced down to about 100 ml, we changed the setup and replaced with a smaller flask. And then, to remove the water a bit more gently, we applied a vacuum and slowly boiled this off. Getting all the water off was a slow process and took over 2 hours to complete. But here's the result. A cake of what looks to be fairly dry solid in the flask. And here's our crude product. 19 grams of piperidine hydrochloride. This is greater than the theoretical amount that can be produced, so it's obviously still got some water in it, and maybe some sodium salt impurities. To take it up a level of purity, we placed the solid into a beaker and then added around 60 ml of absolute ethanol. The idea was that this would dissolve the product but not the sodium chloride or other inorganic salts present. On heating, pretty much everything dissolved apart from a very small amount of white powder remaining in the bottom of the beaker. We let this rest and then decanted the clear ethanol solution into a clean dry flask, and then set up to distill off the ethanol, and hopefully also drying the product in the process. After oven drying, here's our product. 15.4 grams of piperidine hydrochloride powder. Well, this corresponds to an amazing 95% yield on starting pyridine, which is a bit too amazing for our liking, so we're sure there must still be some impurity in here. But probably not too much. The color is slightly off-white as you can see, and the pure substance should be white. But we're pretty happy that we didn't blow our leg up in the process, and despite the amount of expensive ethanol and sodium metal consumed, it's a good achievement. Do know that if you want to do it yourself, it's 2 whole days of work. We'd like to recrystallize this, but we can't find out what solvent to use. We did do a small experiment though by dissolving about 1/4 gram in methanol to form a solution. Then we added some ethyl ether. The piperidine hydrochloride precipitates and can be filtered off. So this is one method to purify to obtain a white solid, if you want to. So there we go. The YouTube first, piperidine from pyridine via reduction using sodium metal in ethanol. Thanks for watching, and please consider sponsoring our channel via Patreon. Check out the link shown here. Stay tuned for more reactions soon.